it deal on multivariant sequence of data like that. Then another thing is a dynamic discipline. Dynamic discipline, you already know, is not a discipline that you will leave today, come back tomorrow, you will meet it the way you left it. Never. What I knew 4 months ago is not what I know today now. So it's a multi-domain, multi-class discipline, right? If you have questions, please take them down. So also, I would define data science as a very collaborative discipline. If there's anything that is very collaborative in the world, is the world of data. But first, someone want to ask, what is data, right? So data is a building block. The way DNA is to you, that is what data is to the business world. So data is a building block of every system, of every organization. That's how we define data is a building block, right? So another thing about data science is a discipline that is solving real-life problems, right? It's a discipline that provokes deep and systemic thinking as an individual. Data science, or the world of data, is a bit very, very different from what you know. It's not UI, it's not UX, it's not the front end or the back end guy. You will get to understand in the course of the lecture. So I think that's just what I was to say. Let me just quickly dive to my slides. So first, we're going to walk into what is data. That I believe I've done, right? And also, we're going to walk into the technical skill needed by a data scientist. What are the non-technical skills that are needed by a data scientist? What are the tools data scientists or those in the world of data use? And the most fundamental question is, why data? Why data science? Then what are the roles that you can find, where you can find expression if you know about data, right? Then we're going to walk into the difference between data science versus data analysis, data science versus data, the artificial intelligence, then machine learning, and salary range, and the whole roadmap of data, right? So, before I go in deeply, if you can still hear me, I would want you to indicate by raising up. Give me that thumb, please. Raise your hand up. Let me know you can hear me. Yeah, makes sense. Thank you very much. I appreciate that. So let's dive in. So like I said, I'm already done with this. So like I said, I'm already done with this, right? So let's just go into what do data scientists, what do they do? So I'm going to talk from a personal experience. So the work of a data analyst, of a data scientist. Okay, let me talk of a data scientist. So it's all about just getting the data, drawing insight from the data, right? Making the data to make sense. Make the data to make sense. Then also the so-called data transformation. You can transform the data into something very, very differently from how you meet it. So is the work of a data scientist is like someone that went to your village to go and buy a land, or went to somewhere anywhere to buy a land. You just buy the land. That is a data, right? How you clear the land, how you survey the land, how you start mapping the land, how you start planning how to work. It's a whole lot of heavy lifting. So I don't want to bore you with modeling process, create algorithm, predictive. Those are high level stuff, right? But for you who is new, I want to know that the work of a data scientist is to get access to a company data. Someone opens a supermarket and has been selling for 5 years, right? He wants to understand the 5 years historical data. What have I done in 5 years? I want to understand my customer demography, the qualitative and the quantitative aspect of my data. I want this data to make sense because I want to project for the next 5 years. It's not the work of a data scientist. Remember, the funny thing about that's why let me come in this way. The funny thing about the work of a data scientist is when the back end and the front end guy they just build the systems like that, right? Remember, when they build, they don't build having the data guy in mind. They just build a system that can tell you name, address, phone number, and those small low-level stuff. But when the system is capturing this data from the front end, when the customer comes and captures this information from the front end, when the data drops at the back end, my people, that is where the whole trouble starts. The data becomes very scattered. Sometimes the algorithm on the back end becomes broken. The data becomes very, very messed up. In fact, is estimated that 98% of the data that company collect in Nigeria are messed up data. You can't make informed decision with those data, right? That guy that does POS business, right? Like Opay now or PalmPay, I'm not supposed to call it, but Opay and PalmPay, right? If they collect data, go to the back end and see their data. You'll be shocked that those data, the POS guys are collecting from the trade, that collecting agent are using to do POS money collection. When the data are dropping at the MI system of Opay, if you pull out that data, it's a whole chunk of a messed up system, right? You look, someone who doesn't use it, if you look at those data for 2 days, you will cry, right? That is where the data guy comes in. You will sit with the data. You see that some columns are missing values, some columns, so you understand, you do a lot of pre-processing. You do a lot of pre-processing on the data. You do a lot of missing values imputation. You need to convert those data. You need to do feature engineering. It's a whole lot of high-level stuff, right? So your work as a data scientist is to ensure that you do data pre-processing. You do data pre-processing. Apart from the pre-processing, what you're supposed to do apart from the processing is you sit with the data, look into the data, clean the data, interpret the data. When the data is clean, now is someone that has a fan. You've built a system of how you want the house to look like. Then this data is clean. You now decide what you want to do with the data. Do I want to visualize this data into Power BI? Do I want to visualize this data into I want to use Tableau. I want to use Excel. No. What do I need to do? It depends on the business case now. The business case is, okay, this data, we want to see what is the profitability of this data in 6 years. That is when you now sit down. You've cleaned the data now. The data is now attractive like a very pretty girl, right? It's a pretty lady. You now start thinking, okay, I need to clean this data. That is when your approach now comes in. So it's not about just seeing data, analyze the data, share insight. No, never. All data is not for insight sharing, right? Yes, that data you need to see. The bottom line of every data is to draw insight from the data, right? But not all data involve insight sharing, right? That's after building some data, you say, okay, I walked to a supermarket, right? I got a data. The data is saying that. Let's go on, my people. It's a whole lot of information. Let me just, I don't know how long I have. Is anybody keeping watch of my time? How long do I have for this presentation, please? Let's say 1 hour, right? So another thing data scientists do is you develop strategies for analyzing data. That's what I just said now. By the time you finish cleaning the data, you start thinking, okay, I've cleaned the data. What is the use case? Why am I here? Why is this data being called for? That is when you do data exploration. We do EDA. EDA is you visualize the data. You can plot one variable against another variable. You can plot one column against another column. You start manipulating data. You start doing like a magician with those data. So EDA is a very good visualization tool. You visualize the data. And okay, let me give you an example. The supermarket data I told you I was collected. So after I collected all the data, I cleaned the data. First, the business wants to see the profitability of the data. How many customers have we had in 25 years? How much profit have I made from selling biscuit? How much profit have I made? Those are low-level stuff, right? How much profit have I made from the entire liquor? Let me use the word liquor, all the liquor in the store, all the babies, all the baby things. How much have I made? All the household things. How much have I made? Like, so you cannot say, okay, you cannot do an EDA on the data. The EDA is more like a visualization of the visualize it. Okay, you want to plot what the profit you've made from the liquor against the soft drinks. You want to plot soft drinks against distilled water. So those are whole thing. Then when that's been done, there are companies that you do a lot of machine learning as well. So you might want to use programming language to run algorithm on the data. So the company is saying that Get me the data. Let me see how much I made in 5 years. Then let me make a forecast of what am I likely to in the next 20, in the next 10 years. That's what we now do predictive analysis. So you want to run a predictive analytics, right? So you can do that using machine learning, or you can do that using statistical tools. So you use ARIMA, ANOVA. So a lot of hypothesis tests you can use for that prediction, right? So if you're using machine learning, there should be a use case where you need machine learning, which is the programming languages. Then if you don't want to use the machine learning, you can also use statistical approach, right? To also want to do forecasting, right? And all that. So let's go on. So one of the technical skill for data set is statistics. So statistics is very key as a data scientist because you're going to be doing a lot of hypotheses. One way hypothesis, ANOVA, a lot of hypotheses. So don't worry, it's not those hypotheses that you know back, but it's going to be based on the knowledge. So data science is more of a domain discipline. So if you have very good background in mathematics, you'll be very, very good in interpreting some of those key data, statistics. You do a lot of linear algebra, calculus. These things are inside data science. If you don't know this domain, it's going to be very tricky for you, right? So it's good to know a bit of statistics, you know a bit of calculus, algebra, linear algebra. There's non-linear, there are linear data, there are non-linear data. So if you have no knowledge about this, you might struggle a bit, but trust me, if you're smart, you're going to find a way. You're going to find a way around it. And another skill is programming and coding. Someone is not going to, okay, why do I need programming? Why do I need programming, right? You will need programming because for you to be able to interact with most of this data, whether you're using SQL, you're using Python, Ender, or Visual Studio on Jupyter Notebook, you will need to interact with those data. And the way you interact with the data is by using algorithms, right? You're going to be using a bit of code, right? It's not, don't worry yourself, you're not going to be building code beginning to the end, but you need code to interact. If you want to fire, if you want to trigger responses to this data, I want the data to tell me if you want your data can only understand, because immediately you feed your data into your Python environment, automatically it becomes a binary data, and you can only interact with the binary data by firing it Python or SQL, whatever you need to, whatever platform you're using, right? So you need programming and a bit of coding, but not more. Coding is not, you're going to be writing code from beginning. No, you're going to be writing code to elicit a message from your data, from your environment. So don't worry. Another skill is predictive modeling. Predictive is, there's a project I ran, right? I got, for those of you that know Tesco in the UK, I got Tesco data, and I needed to predict all the stores, all a particular sales, if FMCG's product inside Tesco, from 2020 to now, right? I used 10 stores data. I got their sales data, right? So I want to predict a particular something. There's something I need to do, right? So the model I used was the predictive modeling. So you can use random forest, you can use XGBoost, you can use light GBM, you can use extreme gradient boost. There are a lot of tree model. We call it tree model. They are the regression model. So for predictive modeling, you use more of regression model. So I use regression model. When you want to, if you hear the word predictive modeling, what comes to your mind is you are using the regression model for that. So so that is under machine learning, right? That is under machine learning. So you also need to understand what is machine learning, right? Supervised and unsupervised machine learning, right? Deep learning, data wrangling and preparation. So data wrangling, how to get data. You don't have the data. I just enter I enter your site, like Emmanuel's site now. I want to get your data. We can do data wrangling, like scooping data from an environment that originally there were no data. Then also talk of model deployment. So model deployment is another level, another thing in data science. After you've built a machine learning model. After you built it, you want to deploy it, right? Deploy is you built it inside your Python environment, but the manager, your boss, does not know what is machine learning. He's not interested. He don't care. He doesn't want to, because he's a chartered accountant. He doesn't care, but he needs to understand what you spent 2 weeks doing. What is it called? You use a data preprocessing, you do hyperparameter tuning, you do modeling, you split the data, you train the data, you evaluate the data, you do data hypothesis, you train the model, and after you've trained the model, at the end of the day, you're able to get a model that makes sense, that give you high accuracy, high prediction, high recall. Or apart from all this one, if you train a regression model, you've seen a model that gives you a very regression value. If you want to use the metrics of, let me not go into those high level stuff. So the guy does not care. He doesn't fucking care. He just want, okay, you've done this thing. Peter, show me how you've been able to do what you did with this Tesco data. So model deployment can happen in two ways. You deploy the model because of non-technical stakeholders, right? So people can just say, oh, you just press 2 + 2, just click on predict. Bam! To tell you the next 3 years, this is what you're going to get if you do that. So data deployment, most times you deploy it, either you can deploy on Azure, Microsoft Azure, you can deploy on AWS. There are a lot of deployment platforms you can deploy. When you've deployed, there's something called production. You've deployed, but it's not live. It's in a particular environment, right? Production is after deployment, you send into production, meaning that the data science team have built a machine learning model, they've deployed it, they like the result, bam, to send it to production. Production means everybody, the sales unit, the HRO unit, the CEO, everybody in the company can have access to that result of the model that you guys built. That is production. Production is deploying, putting it out there for everybody. If you click on your bank data, for example, you can click on, for those, I don't know about Nigeria banks, see if they have this thing. So there's a place you can click, you will now see graph, a whole graph of what you've done, right? There's a training process. That you're seeing is a model that has been deployed and is in production. You can interact with it, you can click on it and query the data. You can query the model that has been built, right? That is when the model has been sent to production. So the difference between model train the model, you deploy the model, then you send the model into production. Then data visualization, like I said, you can get a data set and just put it on your Python notebook and you visualize the data to say, okay, how many did I sell? What have I not sold? And all that. Let's go on. I don't want to waste too much of your time. So another thing about it, for non-technical skill you need as a data scientist is you need a business knowledge, right? Because you need to be very, very proactive. You need to be able to know how to interpret data. So numerical skill is key. Don't be fooled. Data science is not meant for everybody, right? I've seen people walk up to me in when I was in UK say, Peter, I don't think I can do this anymore. Like a lady came to my place, she was crying. Why are you crying? He said, do you think data science was something different? I saw data science look interesting when you look on it from the outside. But when you're exposed to domain knowledge, when you're exposed to domain problems, you start considering that, is it what I really need? So if you're not a passionate thinker, if you're not a curious person, you do not have the business knowledge, you're not curious, you're not a critical thinker, right? You're not very, very collaborative. Your communication skill need to be top notch, because as a data scientist, it's all about presentation. You've been able to interact with the data. The guy who doesn't know, the driver, the company driver is just coming to a board meeting. He wants to see what is model. He doesn't care. Tell me, I'm a non-technical person. Explain to me in a layman's language what you've done, interpreting, drawing data set, do preprocessing, training, missing values, EDA. He doesn't fucking care. Tell me what we've done. So you should be a very hyper good communication. You should know how to collaborate. Collaboration in the sense that when you're working on a project, right, it's not just you. Everybody in the business unit is going to be talking, okay, daily stand up. Okay, the data, okay, what are the challenges, right? Okay, what do you think we're not getting right? Is data science is a collaborative discipline. It's not just you. It's going to be 3-4 people running, working on a particular model. The job of somebody just could be data wrangling. Guy, go get the data. Use API to scrap out the data for me. Okay, they want to work on a project. They don't have data. You give someone your work in the team is go and scrape the data using API. You go for API data scraping, you scrape the data. It's someone's job in that team to clean the data, right? When that person has cleaned the data, it's someone's job to do EDA. EDA is visualization of the data. It's someone's job to do machine learning on the data. Then when this has been done, there's something they do in the UK here. The data science guys, they will train the model, understand, but there are now data engineers. Those guys are the one responsible for deploying it. You know why they separated it? Because the data engineer, the platforms where the models are deployed to, they are more like engineering platform, cross-functional platform. Microsoft owns some, Amazon owns some, Google owns some, right? So these guys are called themselves, they're also data people, but they call themselves data engineers. That the guys that now deploy the model into production, into life environment. From life environment, they go into production, right? So there's a data science, there's a data analyst, there's a data engineer, there's a data architecture. Data architecture guys are the ones that set up the frameworks that build the building block, the framework where the models are going to be deployed to, right? I just hope I'm helping you. This is me passionately telling you what nobody will tell you. Then application of data science. Data science is everywhere, for selling, for marketing. You can predict. So data science cut across everything. So when you say demand forecasting, you want to be able to walk into the supermarket and say, okay, this sort of stuff is not selling because of so. I get access to your data. Any data I have now, I can query the data. I don't care where the data is coming from. I can query that data and make sense of that data. Give me 2 days, 3 days. I'm going to tell you something about the data that you never know. So when insurance people are having accidents and all that, claim predictions, we can do claim prediction, right? This is machine learning. We talk of demand forecasting. We can use machine learning, or you can also use normal statistical. You can use ARIMA, ANOVA, blah, blah, blah. There's disease prediction like heart disease, kidney disease. You use machine learning as well, right? There's dynamic pricing. You also use machine learning or normal statistics, right? They're cross-selling predicting value prediction. You can also use machine learning, or you can also use statistics. Then in terms of social media, you want to see the click rate, right? The rate at which people click on an advert, right? So you can also use machine learning, you can also use statistical approach for all this. So this is not everything, the application of data science. Application of data science is in every walk of life. So from marketing to social media to automation to credit insurance to sales to healthcare to travel to what is it called? In fact, every walks of life. There's no if anywhere there's a data, anywhere data is sitting. If your business is involving collecting someone's data, yeah, you need data science, right? Unless you're only just people come, they just buy, they go out. But at least even if you're writing the name of customers that come in every day, everywhere. That's why data science is a field that is dynamic, right? But like I said, not everyone is meant to be a data. Some people read data science, but they came out of school, they're just fluffing around all over the place, right? So another thing is, what are the tools for data science? So one of the core tools for data science, they said Microsoft Excel. Yeah, if you even go to the event, they'll tell you, you must know Microsoft Excel. You must know Excel. Yes, Excel is the lowest level stuff. You need to know the most low level stuff you must know before you can excel as a data scientist. Another thing is Microsoft Power BI. You must know Power BI. You must know Power BI, right? Because most of the visualization, you're going to be getting some data. There's a project I did. Is a council here in the UK. They said because when you get to 15 years in the UK, you're still with your parents. You get to 15 years, just go to the council and said, I'm 15 years right now. I want to leave my father's house. You go to the council, you put your name down. Do you know what they'll be doing? They'll be looking for house for you. Government will be looking for house to settle, to take you away from your parents. So They said they have a lot of data of young people who want to leave care. When I say people want to leave care, who want to leave their father and mother's care, they're 50, they want to have their own house. So they have a lot of young people. The data are messed up. They want us to sit with the data and be able to interact with data and present those findings on a Power BI so people can look at the data. So, okay, this and this and this and this and this is what I need. You need to understand about this data. Then if there are challenges with the data, all those challenges is going to be self-explanatory from your visualization on Microsoft Power BI, right? So then there's structured query language. So this is for databases, right? So SQL mainly is for databases, right? So yeah, so if you have a database, like you have a database, like companies that have a database, they collect information that they have a database, you can use SQL to query those databases, the banks, those data, you understand? So like I said, it depends on the problem you're trying to solve. You can use SQL on the data, you can use Python on the data. There's Arrow. So Arrow is a computing mathematical tool, right? Arrow function more like Python and SQL, but it has its own domain use, right? It has its own domain use also. So that's another tool data science use. There's Tableau, right? There's Tableau, and something again that you can also use as a data scientist is there's Anaconda, there's Jupyter Notebook, there's Visual Studio, there's Apache Spark, there's Hadoop, right? So Apache Spark is also more like a library you can use to query big data, right? Hadoop is more like for data analysis. Right? So these are tools. Yes. So basically, these are tools you can use to query your data. Let me just move to why data science. So like I said, there are 2.5 quintillion bytes of data produced globally every day, right? So so it's the job of a data scientist to organize this huge data, right? Every business need insight into their data. Every business needs to understand the patterns eliciting from their data, right? So the onus of providing this insight from that quintillion bytes of items seated somewhere scattered all over the place is the job of a data scientist, right? Data does not, if I say the most, let me leave that. So some of the opportunities include long-term stability and growth in the industry. You already know that there's remote working opportunities, opportunity to relocate easily, increasing demands, multiple jobs option, high-paid jobs and career opportunities. So yeah, so the opportunities inherent in being a data scientist is endless, right? Because but you need to pay the price. You need to pay the price, my people. So so the career roles in data science. So data analyst, data engineer, database administrator, machine learning engineer, data scientist, data architect, statistician, business analyst. I don't know what business analyst is doing here actually, right? Data and analytics manager, right? Artificial. Okay, let me leave that. So these are some of the rules that are inside the data science, right? But I'm gonna break this down into more detail later, but have it at the back of your mind that the career pathway for a data scientist or someone in the world of data is different, right? Your work is an everyday thing, right? It's an evolving job. So you need to be very interactive. You need to want to go over and beyond, right? If you want to be very good, you need to pay the price. Just trust me. There's no easy way to be in the data science. I've seen friends struggle, right? One of the skills you need to learn as a data scientist, if you want to be in the world of data, you need to be able to not rest while people are resting. You need to be able to be running while people are trying to see. This thing doesn't give you a break. The life data science role does not give you a room to catch a break. Just rest for 3 minutes. Let's rest. there's no catching or break, right? You need to always be on your toes. These are things high level some people won't tell you if you want to be very good. So the work of a data scientist versus analyst. So data scientists work on new ways of capturing and analyzing data using raw data, statistics, and deep learning to create prediction analyze opportunities. So data analysts make sense of existing data with the search of drawing insight. A data scientist can do the work of a data analyst. A data analyst cannot do the work of a data scientist. It came like a shock to you, right? I can do the work of a data analyst. I can do the work of a system administrator. But a system administrator cannot do my work as a data scientist. They don't build algorithms. A data analyst does not build machine learning algorithms, right? They don't do that. They don't do that. They can give you appealing visualization. When it comes to predicting, using your model to make predictions, to elicit, to build models out of it, right? They don't do all that, right? There's a work I'm doing right now. So after I finished that test coding I told you guys about, after deploying, I trained the model, I saw the model, I saw how lovely the model is. Do you know what I did? I saved the model out of my notebook. I saved it to my computer. Then I deploy it to a Flask, a web app. I deploy it to a web app, right? That's deployment. I deployed it to a web app. Then after deploying to web app, I was able to I built a front and a back end. I built a front and an HTML system to query the data, the model I built in a live environment. Then when that's been done, I deployed the model into Microsoft Adobe. That is production. I send it to production. When it's into production, anybody can query that system, right? But a data analyst cannot do this, right? It can only query data, draw insight about the data, but when you go into machine learning, no, that's high level stuff. That's not their job. So data science versus artificial intelligence and machine learning. So let me make this clear. So artificial intelligence makes a computer to think like a human being, and the only way it thinks like a human being is, so the core of artificial intelligence is machine learning. The DNA of artificial intelligence is machine learning, right? So it's machine learning. That's the core of artificial intelligence. Why the core? The core of a data science is we can use statistics. We can also use machine learning. So the data science guy can either use statistical approach to tackle a data problem, or it can also use a machine learning approach to tackle it. When you say machine learning as a course, right? So machine learning is more like a subset, or is a domain inside artificial intelligence, is a domain inside. So machine learning does not sit on its own, right? If you see data science, they say you must know how to use arrow, you must know how to use machine learning, you must know how to have knowledge about artificial intelligence, right? They don't say we are recruiting for machine learning engineers. Yeah, machine learning engineers, their work is just to just build models, right? But the high level stuff of interacting with the data, pre-processing the data, cleaning the data, splitting the data, dividing the data into 3 sets, test, evaluation, then the whole data set. That is not the work of the machine learning engineer guy, right? So when that's been done, you now train the data on the machine learning platform. When that has happened, that is when the machine learning whole. So let's move on. So salary range. I know you guys are very interested in salary. There's quite a lot of money to make from being a data scientist, right? The beginning is not always very, 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 very easy, right? You need to be consistent. You need to be passionate for you to break into this whole industry, right? I remember when I was a young school leaver, when I said, I don't want to, I want to just get any job, right? I got a job as a salesperson. I started selling. From 1, I sold 2. From 2, I grew to become a chief growth manager. I work in cellular or thing. For those of you that know, I work in e-settlement. I worked a lot of all these POS company like Pampe and the rest. Like I grew to become chief growth officer. Like I was in charge of the entire revenue stream for Nigeria and 1 or 2 countries. I was making money until I woke up one morning. I said, I don't want to sell anymore. I have so much knowledge about sales. I want to move my career to become a data scientist, right? And that actually helped me, right? Because the domain knowledge that I know about data, I know how to use Excel, I know how to use Power BI, right? When I became a data scientist, it helped me, right? It helped me a lot. So domain knowledge is very key. And so forget the salary thing. There's a whole lot of money you need to make, but I don't use salary as a conversation. Pay, there's a sacrifice you need to pay to break into this. It's a very rewarding career, my people. It's one of the most rewarding career on earth. I'm not lying. It's one of the most rewarding career if you're willing to pay the price. Then roadmap to succeed as a data scientist. So you need to learn the basic of coding. Like I said, you need this basic for you to clean your data. You need this basic for you to clean your data. You need this basic for you to understand what is inside your data. How do you interact with the data? How do you get information from the data? How do you embrace the data like a fine girl, right? You need the basic of coding for you to be able to interact with the data, because the data is going to be seated in a Python or in an SQL environment, and you need this basic coding. Don't worry, the basic coding are low level stuff. They're not going to stress you. From 1 you enter 2, from 2 you enter 3. So another thing you need to get, another skill you need to have, you need to be able to make yourself motivated to learn. I told you, I've seen people come to me crying bitter. When I came to the UK to learn data science, I saw people come to me after class to say, bros, I don't think I'm in the right place. So I said, why? They said, I think I should have gone and do international business. I said, why do you feel so? Say, this data science, we thought this was a fine girl you can just see on the street and just talk to her, you just agree. Say, but this, they will use one word. They say the data science is not data in, there's a language they use. The course is not entering, I'm not understanding it, right? The code is not coding, the data. God, I saw people that were shattered, mentally depressed because, and it's not something they can back away, because if you back away, your visa was tied to that, right? If you back away, meaning that the school is going to revoke your visa and send you back to wherever the heck you came from. So you need to learn a skill. If it's a Python skill, just have a passion to learn. You work on project and case studies. You can see this on Kaggle. You can see this on Coursera. You can see this on Codecademy. There are a lot of platforms you can work on project and build case studies. GitHub is also there. You build a portfolio. You can join communities and networks. You can volunteer for jobs, and you can look for internship opportunities, right? Then you can apply for jobs. Then most importantly, you keep practicing, keep learning, keep trying to upskill, right? Because I've seen people who just learn this thing, they do not want to upskill. They just learn it, they just become very relaxed. So I think these are the things you need to learn as an individual, right? Basically, I think I don't know if that should be the end of my presentation. Thank you very much, and I don't know if you have questions for me. Sorry, there's no way I could have made it more simpler than the way I've made it. Data science is very, very technical. I wanted to walk you through every nitty-gritty you need to know. I'm not stingy with information. I'm not stingy with information, right? So I think that's it. So if you have questions, we can take your question right now. Sorry I bored you, right? Sorry the class was boring. I apologize. So can we take your question?
All right. Yeah, thank you so much, Peter. Thank you. I really learned a lot personally. So thank you so much. So I don't know if anybody has questions. In fact, you must have questions. Yeah, I have plenty of questions, but I feel I should just give others a room to ask their questions. So we take it up from there. So if you have questions, you can unmute or you type in the chat box. I'll read it, then he answers the question. Let me check. I think we have some messages in the chat box. But if you have your question already, you can unmute and ask. Can anybody hear me?
Yeah.
Hi, Pascal B, do you have question? You're saying something.
Yeah. Sorry, I thought you asked. Okay. Very, 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 very fantastic presentation. Thank you, Mr. Peter. The question I wanted to ask is that me, I enter here for analysis. So,
Yeah,
but
you okay?
yeah.
Yeah.
So, but you are trying to be very honest and very factual, so that if you like them, you come. If you don't like them, you dialogue, which is awesome. But what I want to know is that for the data analysis side, you didn't talk about the maybe career projection, salary projection. I know, like you say, you don't want to use salary for all that, but I mean to ginger us to then do now analysis need Python and R. Is it supposed to just be Excel and SQL, SQL and all that? Just a small brief stuff on data analysis. That's what I want to know. Then degree level, is there a must have that? You're already practicing in the UK, so you know what's obtainable in the international level. Thank you.
Yeah. So Pascal, let me come to you in this way. This Utiva advisor, is this what's your name again? Sorry, this lady from Utiva, what's your name again?
I'm Rachel.
Rachel, please, you're going to forgive me. I'm going to talk like a man. So data science is like the principle of a condom. It's like the principle of a condom. Better to have a condom and you don't need it than need a condom in the moment of the action and you don't have it. It can be very embarrassing. So data science. So Pascal, this is how I'm going to answer your question. A data analyst cannot do the work of a data scientist. I can take your job, but you can't take my job. If you can understand it from that way, it's going to help your thinking process. So a data analyst can query your data, but again, it depends on where you're working. Every company have their domain. They have the environment domain, how to query their data. Some will say, let's just use SQL to query the data. They don't care. Just download SQL and be querying the data like that. They don't have much problem. So it's okay, let's use Arrow to query the data, right? They just want statistics. Use Arrow to query the data. So I would say use Python to query the data. So it falls on you as an individual what you need to learn, right? And if you learn only Arrow and the job demands that you use SQL, what happens? Are you not going to do the job? So my people, the knowledge are interwoven. If you learn SQL, you have an idea already about Arrow. It just want you to understand the technicalities of every domain, right? Eotago. So the technicality of every domain, right? You need to understand the technicalities of every domain. Python has its own technicality, Arrow has technicality, and SQL has technicality. But like I said, there's also another called Visual Studio, right? So all of them, they have their own technicality. But remember, if you know Python, you're standing very pretty. You're standing very pretty, right? Python is a multi-class domain you will need. A company can say, if you know Python, you have already you can use SQL. Yeah, you can use SQL, right? But if you know SQL, you don't know Python. So these are the technicality and all that. So let's not discuss salary, my people, right? I like guys grinding. If you're able to grind, you add value to what you're doing. You should be able to make money from the whole system. So don't let money be a factor. Don't let money be a factor. Upskill, and upskill. Yeah, I'll leave it there. Thank you.
Thank you
All
very
right.
much.
Yeah. Thank you so much, Peter. I think I just want to add a little to what he said. I learned data analytics. When I started, after my learning, I was trying to get a job. Then I discovered that most of the job descriptions, they are asking for what a data scientist can do. You will see, they will tell you the job title is data analyst, and they will tell you must be able to use R, you must be able to use Python. See, I at a point I had to go and learn Python because I could not really secure a job, especially the salary range I wanted. Now, if you want a data analyst, they will just use it as data, maybe all this data entry. That's basically what you will get if you're only doing Excel and the like. So it's okay if you go for, what it's trying to explain is, it is okay when you are over prepared. Let me just speak it that way. So you are not caught unaware. Any industry or any company you see, it makes you more fit for the market. I think that's just the word. It makes you more fit for the market, because some company will demand for something for data analytics, and yet looking at everything they listed is for a data scientist. That means you are not fit for the job. And as a data analyst, you're a data analyst. But all the job description, the tools that they mentioned, you can't use them. So you're not fit for it, even though you're a certified data analyst. So it's okay if you learn more. Let's be over prepared for the market. That's basically what he's saying. Thank you so much, Peter. Thank you.
Thank you, Richard. What I'll also add is, I keep telling people, if you want to compete globally, please do not limit yourself to what you know. Don't learn twice, right? Like I said, I can do your work. I can do the work of a machine learning engineer. But a data analyst is just limited. You're just at the lowest of the food chain. Don't do that to yourself. Thank you.
Thank you so much. Thank you. So we have a question in the chat that says, in relation to the timeline to move from 0 to expert level, how long do you think it will take to accomplish this? That's a question.
So there's a domain knowledge, right? I was talking about statistics and so many things, right? One of the biggest blocker you will have when you're learning data is your domain knowledge, your transferable skill. What knowledge do you know about the data, the statistics, algebra, all this high-level stuff, the business knowledge? How can you interpret? How do you look? If you've seen data, if someone who have sat in front of Excel, you've looked at Excel. So your knowledge of Excel, your knowledge of Excel, your knowledge of statistics, your knowledge of algebra, quadratic equation. These are those things that will make you catch up, right? For people, I just told you that I have a girl, or 2 people, 3 people, or 4 people. One was even in my house 2 days ago. They had been a project and she's messed up. She doesn't know how to continue, right? It's your transferable skill, your domain knowledge, and what you've known. Where are you coming from? What has been your journey? For me, I did very well. I graduated distinction from University of Salford on data science, because one, not that I know about data science, but because I have transferable skill. I'm able to look at data. I've seen data. I've interpreted data before. So I got a soft landing compared to people. But the biggest challenge we have is, how mentally are you prepared? Some people, they see coding, hey, they become hysteric. Coding is like the big Ogbanjen they had. Don't want to see coding. They're running. Their brain is shutting down. So one of the greatest challenge people saw when they came to learn data science was when they saw Python. Everybody started breathing. Python is in the building. Respect for Oga, big boss. When you see Python, people start fidgeting, right? When you start seeing machine learning. So mentally, it's not something you rush, right? The rate at which I grasp as a person, my people is like, won't get caught, but one Indian lady says, excuse me, Peter, you're always asking good questions. You've known about this before? I said, no, I've not. He said, but you seem intelligent. I just laughed. But it's interest. I wasn't sleeping consistently. I was doing that, burning that midnight oil. People are sleeping. I was awake, looking at code, running inside environment. How prepared, how hungry are you? You need to pay the price. That's what I want to tell everybody. See, there's no shortcut to be a data scientist, please. Coding is not your problem, right? Maths, if coding is not your problem, then math is not going to be your problem. Trust me. If coding is not your problem, mathematics is not going to. If you can get coding correctly, if you can get coding correctly, trust me, you solve 45% of your problems. Mathematics, if you're already coding, no problem. Mathematics is not going to be a problem. You can always see mathematics in more in R. You do a lot of mathematical thing in R than for hypothesis, right? But there's a shortcut around the mathematics, right? So if there's something called analysis of variance, ANOVA, for those of you that have done statistics. So you're going to be needing mathematics in machine learning, but it's low-level mathematics. You're going to be needing more of mathematics in statistics. If you can code, go the machine learning route, leave statistics, right? So there are two gateways: the statistics gateway, the machine learning gateway. You want to use statistics and throw away statistics. You might want to use statistics, but like I said, the presence of AIs, a lot of chat are there. You can learn, use ChatGPT to learn, query what you need to learn. So the presence of AI makes the learning process a whole easier for everybody. So yeah, I think that's what I want to say now. Thank you again. Thank you.
Thank you so much, Peter. Olufemi, your hands are raised. Let's take one more question because we have to go back to the main room by 12:45. So let's take one more question. If you still need clarity, I'll be dropping the contact of a learning advisor. If you want me to explain more or you want to speak to the learning advisor at TIBA. So Olufemi, let's have you, sir.
All right. Good afternoon, Ma. Can you hear me?
Good afternoon. Yes, I can. Yes.
All right. Good afternoon, Ma. Good afternoon, Mr. Peter. Thank you for the lectures. I've learned a lot. My own question is that currently where I work, I'm into product management. But of course, we have the MIS team, we have the data science department, that supplies us with the information we require. But most of the time, because we report, directly to, we have a direct boss that we report to. And if the data science guy do not give us the information we need, we just seem to be at their mercy. So an event actually happened in the course of this week, that was, in fact, I've never been embarrassed that in the last 7 years that I've been working. And that's because I don't even know how to maneuver my weights on the Excel. So that was when a friend now introduced me to Utiva. So my question is that in the courses, because I am more interested in learning advanced Excel, I just want to ask that how practical will the classes be? Is this such that maybe at the end of the day you'll be able to maneuver your way, then you can actually do it practically? As in, it's such that even if it's going to be an online sessions, it's such that at the end of the day you'll be able to learn how to use the Excel, all this Power BI Excel very well, that you wouldn't have to rely on the data science and be relying on another department to give the information that I could as well do myself. Thank you.
Richard, before you speak, right, let me answer him. Let me answer it from an industry perspective. You can answer it from that Utiva learning course, whatever. So, Femi, let me make this clear to you, right? You don't have access to the data. The data you need to work. The data is the job of a data scientist. That's why I use the word that it's a collaborative discipline, right? I don't know if your company allows you to access the data yourself, if you can access those data yourself, right? Can you answer that? Does your company give you access to the
Yes,
backend?
I have access to all the data myself, but working on the data, that is the challenge, that we have to rely on the data science team to prepare the report, and we will have to present and speak on the report. I want to be able to maneuver the Excel, do all of those things myself. I have access to the data.
Okay, great. So what you do is, if your data is a takeaway data, if your company domain allows you to take your data home, Utiva, I'm going to leave Rachel to speak to that, right? So yeah, but it's okay. I think Rachel can speak to the environment you're going to be learning from and all that. So Rachel, you want to talk to that?
Okay, yeah. So you will actually learn Excel. You'll be able to learn Excel, in depth about Excel. So for data analytics, you're learning Excel, Power BI, and SQL. So the learning structure, it's hybrid mode of learning. Hybrid in the sense that you have access to a student dashboard where you have content that have been recorded, videos and PDF that you will read. Then weekend you come online for a live class. Online class on Zoom where you have access to your instructor, just like what you're experiencing today. So unlike a recorded video, you can ask questions. If your instructor is doing anything on Excel or Power BI or SQL that you don't understand, you can easily call him or her back, get clarity. So that's what the live class entails. So that's how the learning is structured. I don't know if I'm able to answer your question.
Yeah.
Yes, thank you.
Yeah, Henry.
All right. Okay, Henry, let's have you. Hello, Henry, can you hear me? Oh,
Rachel, let's just go on with the meeting. Maybe we just go to the main room. Is that okay?
okay, yes. Let's just go to the main room. But I think we have just a question here.
Yeah.
In the chat box, we have a question. How best would you go about becoming a data analyst if you're a beginner? What is the roadmap you used? And kindly share best resources to use apart from the training Utiba offers.
First and foremost, right, for a beginner, you need to know about Excel. You need to know about Excel. So your go-to resources first is Excel. You need to be able to understand the nitty-gritty, how to work around Excel. So for a beginner, I will first say, sit down with Excel. If you've been able to master the use of Excel, you solve 60% of your problem as a data analyst, right? You solve 50%, 60% of your problem as a data analyst, right? So data analyst, then we'll be able to understand Excel. Then you start picking up SQL, right? But I think that is what you need to first learn Excel. Don't bore yourself with too much knowledge of Excel, no, of SQL, no. First learn Excel. If you're good at Excel, trust me, as you can do the work of a data analyst effectively, right? It's just high level stuff that has to do with Excel, Python, that you need to start breaking out to go and learn. But if you can master Excel in and out of Excel, trust me, you're good. There's no way. You're very good. You're good.
All right, thank you so much. Thank you. So we'll be going back to the main room. So for data analytics, we are going to learn in depth about Excel. So I'm dropping the link to the main room. But before we go, can we just say thank you, send emojis, do thumbs up. Let's say thank you to Peter. Personally, like I was just glued to the screen, like, okay, like let's just give thumbs up. Thank you. You really made it easy. Honestly, you made it easy. You simplified it. Thank you. Thanks for coming up with a busy schedule. As at yesterday, I was calling him. He was on the move. Was still responding to me. Thank you so much. Thank you. Thank you. Thank you. You're welcome. All right, so I'm dropping the link to the main room now. So that's the link. Click on the link. Let's go back to the main room. The informations we don't want to miss. We will be running promotion anytime soon. I don't know. So you have beautiful information you don't want to miss. So click on the link and let's go back to the main room. Thank you so much, Peter.
Thank you. Thank you.
And thank you everyone for joining. Thank you. Thanks for joining. So let's click on the link. Let's go back to the main room. I'll be ending the call once it is 11:45 for everyone. So please go back to the main room. You are going to have more clarity. Tell them how much Peter have done. Tell them, I don't know, but I really wish,
the very best. So I don't want to go into that. Just sit back and relax while I talk about how learning at Utiba look like. All right. So we have program flow, which is hands-on learning. Please give me a thumbs up if you can still see my screen and if you can hear me. Okay, great. Thank you so much. Now, for hands-on training at Utiba, when you enroll for a course, you have what we call personal learning. All right, you have a personal learning dashboard where you get to learn at your convenient time.
Please leave the call, Pascal. Everyone, please, let's leave the call now. Let's go back to the main room.